Hello and welcome to EE233. I'm your instructor, Gregory Myers. In this video, we're going to focus in on our add file data and our remove file data. Conspicuously enough, in this example, we're actually going to do no file input or output. Rather, what we're going to do is we're going to set up our add file data and remove file data to call another function based on the data type that has been passed to it. So essentially, our add file data and our remove file data become somewhat of triage functions, meaning that they assist your main with handling particular input arguments, specifically your data type. So what we're going to do in this particular example is we are actually going to, in our add file data, we are simply going to triage our data type. And then based on how we triage or what we discover from our data type, then we will pass the information along to the appropriate function. Since we have decided in this particular example that we are going to handle ints, doubles, and a single char, we need to be able to have variables that could handle one of those data types. And so what we're going to do is we're going to start off, we're going to create an integer. Now, my data variable is already used. So if anything, what I'm going to do is I'm going to create another variable and I'm going to call it a int data. Perhaps not the best variable name, but it's going to allow for us to distinguish between the different types of data that we're going to be handling. Likewise, we're also going to have a double data. And then lastly, a char data. Now, it's important to note here that for this particular example, this is actually going to represent a single char. We're going to come back in a later video and look at how to deal with words and other more complicated structures. Instead, what I want to do is I want to focus just on these three simple data types. And to begin with, what I want to do is I want to use my string compare I function, and I want to compare the value that was passed using the data type variable, and I want to simply I want to simply compare it to either an int, a double, or a char. So in other words, in this case, if that is equal to 0, we want to call our add file int. Else if my string compare I found that my data type was a double, then I want to call my add file double. And then the third one is going to be to compare my string compare I to my data type. And if it's a char, then I want to make a call to add file char. Of course, under my else, I've ran out of options. So in this case, I would at least want to print out some sort of message to the user saying error unhandled data type. At this point, then, our results would simply be equal to 0 to indicate that nothing was done. Now, what we'd like to do now is turn our attention to the data that is being passed to this function. And so if you notice, we said earlier, we're going to treat everything as strings until we get to the point of calling the specific functions that have to be concerned with the data types. And so in this case, basically we're getting a string that we believe holds an integer. And so what we want to do is we want to take a look at how to convert that string into an integer, but we'd also like to take the extra step of validating to make sure that it is in fact an integer. Now, one way to go about doing this is to use the A to I function that you've probably already used in an earlier project. And if you notice here that basically what it does is it converts a string into an integer. And if there is no numerical sequence, it returns a 0. This leads to an interesting problem. What if the user intends to pass 0 in a string? Well, we're going to do a little bit of additional error checking here in that we're going to use the A to I function. And if we encounter a scenario where the return value from A to I is in fact 0, we're going to go back to the originating string to see if it also matches 0. We're going to do something similar with the A to F function, with the main difference being there that it will silently fail, returning 0, in other words, 0.0. So what we're going to do is if we do in fact get 0 from the A to F function, we're going to check to see if the user intended to enter in 0.0. Once again, perfectly acceptable. We just want to make the additional check. So how are we going to do that? Well, we're going to start off by simply using our int data variable and our A to I function, and we're going to pass to it the data string. Now, as I said earlier, if our int data was equal to 0, we need to make sure that the user did in fact intend for that to happen. And the way we do this is we use our string compare I function one more time. And in this case, what we're going to do is we're going to compare the data to literally the string 0. In other words, do they match? And the only time we want to proceed is if this is not equal to 0. If you recall, the string compare I function returns 0 when there's a match. So if there's not a match between the two, then we're assuming then that the data did in fact end up being 0. Put another way, if int data is equal to 0 and the string that was passed in data was not supposed to be 0, then we have a problem. In other words, we simply have a printf error failed to convert integer. And at this point, then what you can do is you can provide a %s because it is still a string and a new line and pass to it simply the value that is stored in the data variable. Under the else is where we're actually going to assume then that we have valid integer data, in which case we want to call our add file int. So what we're going to do here is going to say results is equal to add file int. And we're going to pass to it the same input file name that was passed to this function. What the difference is going to be is we're going to jump straight to our int underscore data because now we have converted that from a string into an integer. Now we're going to do something very, very similar to our with our double, in that we're going to have double data is going to be equal to the A to F function, and to the A to F function we're going to pass once again our data. And what we're going to do is if our double data is equal to 0.0, by the way, a little minor typo up here. Notice that I have a single equals. That's supposed to be a double equals because it's a comparison. If the double data is equal to 0 and string compare I attempts to match the original data with 0.0, this time it's in quotes, and that is not equal to 0. In other words, there is not a match. Then essentially what this means is that there was a failure to parse the data into a double. So in other words, error failed to convert, in this case, a double. And once again, since it is a %s, we can actually print it out as such, and we'll print out the data. Else, we're going to assume that we have a valid double data, in which case we simply want to use the results variable to capture the return value from our add file double. We're going to pass to it the input file name, and we are also going to pass double underscore data. Now the converted data from the data string to the data double. Which brings us now to our char. Now, notice we're passing data as a string, but we're only really interested in the first character. And essentially, anything else means that the user entered in more than we wanted to deal with. Now, you could say we could just strip off the first character and blindly just add it to the file. However, though, that might be misinterpreted to the user as success. In this case, what we want to do is we want to actually check to see what the length of the data is. So to do this, we're going to use a built-in function in our C libraries, or you can also use your own string length function to essentially measure the length of the data. And if that is equal to 1, in other words, we're really only interested in one character, then we call our function. Else, we have a problem. In other words, there's either a zero length string or it's too long, in which case we can simply provide a printf error failed to provide a single character. And you can further refine this, if you wish, into separate cases where you are looking at a zero length string as well as too long of a string. Either's fine. But we can provide then to the user some sort of message back to them. From there, then what we want to do is we can now make a call to our add file char. Once again, passing the input file name, but now this is where it gets interesting. We only want to pass a single character. And to do that, then we will simply use our data as a string, and we will only pass to it the 0th index element, thereby passing only a single character. We can do a very, very similar triage with our remove file. As a matter of fact, we can actually go ahead and copy the entire contents of our function here, our add file data. We can open up Notepad and we can paste in. And at this point, what we can do is everywhere we have add file, we can simply replace it with remove file. And copy it back. Now, I don't expect this to be perfect, but this should get us a pretty good ways along. So we paste this in here. And we probably want to take a second just to review the code. But once again, since we've set this up properly and we've named our functions consistently, we've managed to accomplish a lot of functionality in a short amount of time. At this point, we can go ahead and build it and see if we have any errors. All right, let's see what we've got here. All right, so we have a number of warnings. Let's go ahead and rebuild it one more time, see if we've got any errors here. Nope, Um, Everything seems to be fine. As a matter of fact, we'll go back and take a look at the warnings at some other point. Um, but at this point, we should be able to go out to our command line, and we're going to go ahead and clear the screen. We're going to focus solely on the parametric mode because we already know that our interactive mode seems to work correctly. So we're going to start off with our add, and we're going to pass the file name a.txt, look for the int data type and the number 2. You'll notice now that I get two messages back. One says add file data and the other says add file int. What we can do now is we can change the data type, to double. And in this case, I'm going to go ahead and provide 2.0. And now we are passing it to add file data, which turns around and triages it to add file double. The last one is going to be char, and just to be different, I'm going to put a letter in here. And you'll notice that it's add file data, then an add file char. So it looks promising. Before we go too far, why don't we go ahead and put in some sort of other data type. So we'll focus on float for just a second, and I'll come back to 2.0. And you'll see that add file data is now followed up with error unhandled data type. Looks extremely promising at this point. Once again, this is the benefit of doing things systematically. We've really built out a pretty complicated program in a very short amount of time. What we can do now to test the features for remove is just go back to the add int and change add to remove. And sure enough, remove file data appears to call remove file int. We can do the same thing now with double. And you see remove file double, remove file data calls remove file double. And then the last one, of course, is char, which is going to call remove file data followed by remove file char. Now, the real stress test on our particular example here is if we go back to our add, and we'll focus in on our int for just a second. And what I'd like to do is I'd like to put something in that clearly is not an integer to see what happens. And so at this point, we tried to convert z into its equivalent integer. A to I would have returned back 0. And we said that we want to do a special check when A to I returns 0. In this case, we want to check the original string. Did the user mean to put in 0? Well, let's see if this actually works when the user puts in 0. Wonderful. We can call add file int if we intentionally want to pass 0. Likewise, if we want to check the double to see if the A to F works, we simply provide double and then 0.0. And you see, once again, that works. But if I put something in like Bob, it's going to say failed to convert to double. So it looks like not only our main switches work, but also those helper functions of add file data and remove file data also seem to work. So once again, I hope you found this video useful. And the next video, what we will do is we'll focus in on the functions that do the work. And we're going to do this for both the add file series as well as the remove file series. So once again, if you've got any questions or comments, don't hesitate to email me, and thank you for watching.